Hi and welcome to Geeks for Geeks. Today we would be discussing the problem plots of gold. Now in this problem we are given a game where there are two persons X and Y and they do both take alternate turns. Now in each alternate turn the task is to select a plot of gold from either front or the back. This means that suppose we are given 1, 2, 3 and 4, then either I can select 1 or either I can select 4. Okay, you don't need to think in terms of plots of gold. Just think in terms of elements. It would be much more simpler. Okay, so if you take the first element, then the reward or the points you would get is the value of that element. If you take the last element, the points you would get is the value of that element. Fair enough. Now there is one more thing that A starts the game. There are two players like A and B. Okay. So A would start the game. And what we need to do is there are two conditions. First, we need to make A win and make him have the maximum coins. Okay. So agenda is not only to win, but to have maximum coins. Fair enough. Now, so how can we think of this? Okay. So the first Okay, so now we have two test cases to evaluate. So the first thing that comes to our mind is A would start the game, that A would select the element from either the front or the back, and then B would also select the elements from the front or the back. And both play optimally. Play optimally means they would play to win and they would take the best decision that is possible. So now the most easiest or the brute force approach that comes to our mind is a greedy solution. Okay, so like we have a way to select either the first element or the last element. So if we want to maximize our point, then definitely we would take the element which is having higher weightage. Yes, we would. So what we would do is we would take down this 8 and we would write it here. Okay, so I would just write here A. Okay, okay. So I have taken this A. Now the next person is left with 15, 3 and 7. Okay, so he would also take the largest element possible. Okay, so he would take this 15. Then I am left with the next 3 as well as 7. So what he would do is he would take the first person would take the largest element, that is 7, and then the next person would be left with 3. Okay, so 7 plus 7 is equals to 15 and 5 plus 3 equals to 18. So definitely, even if we follow this greedy approach, that either from the front and back, I would definitely take the element which is larger, then this is not possible. Okay, so we need to think of a better way. Okay, and you can evaluate. This would be an homework. So you just evaluate for it for this test cases also. In this test case also, the same greedy approach would fail. So looking at both the side and then taking the side which is greater won't solve the purpose. Okay, so how would we solve this? So now the other approach, okay, the winning approach or the correct approach would be for this sample test case that is mentioned here only. Like what he can do is he can take up this 7. Now the next person is only left with 8, 15 and 3. So he has only two options like 8 or 3. Whatever options he takes, suppose even if he takes this 8, okay, he takes this 8, then I can again take this 15 and then he is left with 3. So 8 plus 3, my opponent would be having 11 and I would be having the value 22, which is the largest possible value. Okay, so now we know that the greedy approach is not working. If the greedy approach is not working and we are not able to devise a way where every time by this method we would get the maximum possible, then the next thing which comes to our mind is explore all ways and then return the best. So we need to explore all possible ways and we need to return the best among them. Okay, so whenever you come across the statement that explore possible ways, our solution would be to use recursion. Okay, So now how to solve this problem using recursion? That is also a problem. So now let us move forward. The plots can be arranged in a manner L plus 1, L plus 2, L plus 3 till R value. Okay, this is the left one, this is the right one. Okay, for better understanding, if many people go with I and J, but I go with L and R. Why? Because L definitely means that L means on the left hand side, R means on the right hand side. So it is a good approach to go with this name convention, as according to me. Okay, so now I have this L and R. So now I have two options. Either I would select L, or either I would select R. So if I select L, then my opponent would be left with L plus 1 till the value R, because I have used this L. So L use kar lenge, to fir L plus 1 to R would be left. In the same manner, suppose I have selected the R value, then I would be left with L comma R minus 1. L comma R minus 1 for the opponent. So I selected this L and my opponent has this. I selected this R, my opponent has this. See, my opponent would try to use the best strategy to win, and I would also try to get the best strategy. So now try to think of that in any game theory problem. Just remember this thing, that whatever happens to you would be the worst, and whatever you are going to do would be the best. आप अपना बेस्ट दोगे, वो अपना बेस्ट देगा. वो अपना बेस्ट देगा तो आपके लिए वो वर्स्ट होगा, और आप अपना बेस्ट दोगे तो वो उसके लिए वर्स्ट होगा. ऑप्टिमली का ये मतलब है, in the current scenario he would be taking the best decision. Okay, so now the opponent is left with L plus 1 and R. Okay, now the opponent has two opportunities to select. He has the opportunity to select this L plus 1 or this R. Okay, so now what he would do is, if he selects L plus 1, if he selects the value L plus 1, then you would be left with L plus 2 till R. Okay, so L plus 2 till the value R, you would be left with that. Now if he selects the value R, then you would be left with L plus 1 till R minus 1. So that would be L plus 1 till R minus 1. You would be left with that. Now here also, if I select the R value, then the person selects the L value, or the person can select the R minus 1 value. If the person selects the L value, I would be left with L plus 1 till R minus 1. If the person selects the R minus 1 value, then I would be left with this, that is L till the value of R minus 2. Okay, so now try to think in this manner. This decision, is taken by you. Okay, and this decision is taken by your opponent. Okay, so if you take the best decision, so you are playing and you are playing optimally, so you would take the best decision. That means whichever value would return me the maximum value, I would take in consideration of that. Suppose I have L and R and I'm trying to give my best. Best means I would try to gain as much points as possible. So if I'm trying to gain as much as points as possible, I would take the best out of them. The best would be the maximum value. Okay. Now, if my opponent is doing that, then he would try to provide me with the minimum value. If I'm selecting R, then he would be giving me the minimum value of this and this. If I'm selecting L, he would be if I'm selecting L, then he would try to give me the minimum value that he would get from this and this. मतलब वो तो मुझे minimum value ही देगा ना. Now if I select the R value, then he is left with this and this. If he is left with this and this, then he would provide me with a minimum leftover value. So minimum of this. So what I would do is, if I am selecting the maximum of L plus 1 and R, and then the minimum of these two, Okay, minimum of these two. And if I'm selecting R, then the minimum of these two. Okay, this is what we were doing. Just remember this, and then we would be going back. Okay, so now this thing is quite clear. Why? Because we are having this LNR. LNR would definitely be the starting and the ending position. That would be the parameters. Okay, now I can go in two directions. Either I can select this L and recurse for L plus 1 to R, and I can select this R and recurse for L to R minus 1. Okay, and then I would add this value. Okay, so now when I would start implementing, this would become very clear. Okay, fair enough. Now let us move to the implementation. So as many of you are quite accustomed, whenever we are solving a problem in recursion, I try to name it as rec. Okay, so what I do is I would take the int L and int R. Now what are the other things I require? I require this array to traverse. This is the only thing I require, because L and R is a pointer, but the element at the pointing position would be given by the vector only, no? So I would be having vector of int, and I would pass by reference so that I don't get any unnecessary TL. Now L and R would return me a zero value when there is no element. So I can simply say that if L is greater than R, then I would say return the value 0. If this is the condition, then I would initialize the value answer. Okay, here I would store the value of the answer. Then the first, okay, int. Now I would say left side. If I'm selecting the value at the left hand side, then first I would get points for that. I would get points for that is A of L. Okay, and then there are two options to recurse. So if I'm selecting L, if I'm selecting the value L, then I have two options to recur. L plus 2 to R, okay, and then L plus 1 to R minus 1. Okay, and I would take the minimum of them. Okay, so now what I would do is I would say that yes, this A of L is taken and recurs for minimum. This would be the minimum of them. Recurs for, what was the condition? That is L plus 2 to R. So L plus 2 to R, and then the array. And then I can recurse for the next one. What was that? That was L plus 1 to R minus 1. Okay, so I would say L plus 1 comma R minus 1 and then A itself. Okay, so now I would take the right hand side element and I would name it as right. So if I take the right hand side element, then I would be having A of R and then the same minimum of the next two position. So what were the next two position? L plus 1 and R minus 1. Okay, so I would say rec of L plus 1 comma R minus 1 and then the A itself, and then rec of the next one. The next one was L and R minus 2. So I would say L comma R minus 2. Okay, and then the A itself. Now I would take the best decision because this is left and this is right. So if this left and right decision would be taken by me, see, left and right decision is taken by me, so I would try to get the maximum possible value. So I would simply say that answer is equals to maximum of left comma right. Okay, and then what I would do is I would return the value of answer. Okay, then simply recurse it for. What I would do is I would simply say return rec of 0 comma n minus 1 comma the value of A itself. Let us just compile and run and see. We are getting a correct output for the sample test case. Let us try to submit this. We would be getting a TLE. Yes, we got a TLE. Why? Because the intended time complexity is way less than this. So now we need to optimize recursion. Okay, we need to optimize a recursive solution. So optimizing a recursive solution is absolutely very easy. What you need to do is the most basic approach. Don't think about 2D, 3D, DP, anything. Don't think about two. So now we need to optimize the recursion. In the process of optimization of recursion, don't think about 2D, 3D, DP or anything. Don't think in that direction. Just try to find out what are the dynamic variables. Okay, so A is not changing. So this is not dynamic. R is changing. Why? Because see R minus 1, R minus 2, R minus plus. This thing is happening. Then L. Is L changing? Yes, L is also changing at L plus 2, L plus 1, L plus 1, and then L is remains the same. So L and R is changing. So there are two variables. That means that it is a 2D DP. Okay, so L plus R. So now what you need to do is you need to find the range till which the value can be of L and R. So definitely this R can be from 0 till the value of n minus 1. Is this true? Yes, this is. L value would definitely lie between 0 to n minus 1. And R value would also lie from 0 till the value of n minus 1. Why? Because basically L and R are the index only. So now what I can do is I can declare a 2D array, okay, 2D array of n multiplied by R, and I can pass it here. Okay. Then before the computation, I can just try to find, okay, if this value is already saved or not. If this value is saved, then we would return that. Else we would, if we are coming till this point, that means that value is not calculated and we would calculate that value. So now let us go to the coding part and then we would understand it much better. So now what we need to do is, before this recursion thing, we need to declare a 2D vector. So what I would do is vector of, so I just, it's personal preference. I just try to move forward with vector. Okay, vector of int, and then I would say dp of size n. Okay, that is already given, and vector of int. Okay, vector of int with the value size as n multiplied by n, with the initial elements as minus. Okay, fair enough. This is what we need to do. Now what I would do is I would pass this vector with pass by reference. Okay, so vector of int, and then I would say and of dp. Now I would say that if dp of L and R is not equal to minus 1, then I would simply return dp of L and R. Okay, and if I'm coming till this point, then that means that I need to save the values. So I would say that dp of L and R is equals to the value of answer. Now let us just compile and run and see if we are going in the correct direction or not. Okay, we need to pass the dp here also in the parameters. So let us just pass this. This is a very small error that I overlooked. Okay, and we need to pass here also. Yeah, now it should work fine. Yes, it is working fine for the sample test case. Now let us submit this and see, and then we would talk about the time complexity. Yes, it is solved. So now, as I told that yes, the value of L and R would resolve from 0 till the value of n minus 1 and 0 till the value of n plus 1. So at each step, we are just doing constant operation. So that means that the range of element, that is n multiplied by R, to fill each of the values, we are doing constant operation. So the time complexity would be n multiplied by n. So the time complexity is big O of n square. So that's it for today. Thank you and have a nice day. If you were till this point of the solution, and if you liked the video, feel free to comment your views or just reply with a understood so that the reach of this video gets more. Thank you and have a nice day.